Tonight I thought I'd make a video just carrying on the whole theme of the problems with causality and just having a look at why causality in particular is a bit of an issue. So in order to understand the problem, one has to think of causality really as being expressed by a conditional. So to say that if A happens, then B happens. So if we say that, apples flying through the air causes oranges to levitate. Yeah, let's use a better example. Let's say we say that moving your hand through the water causes waves in the water. So, but we could really use anything. That's the whole point. With logic, we don't have to restrict ourselves to claims that are sensible. As long as we can assign a truth value to them, it can be anything really. I'm not sure if I mentioned this in the previous video. This is part of the very, very important property of logic, which is that of its formality, which means that it's not the content of statements that matter, but it's the form that the statements take that matter. So in relation to each other. And so this really is why it's almost better to use kind of random nonsensical statements rather than sort of sensical ones, if that's a word. It's probably not a word. Rather than sensible ones like your hand moving through the water causes the water to form waves. The problem with using sensible ones like that is that it's very easy to mislead oneself about the nature of logic itself. So when we're speaking about logic, we're talking about the form of the statements, not the content of the statements. It's extremely important for what comes later. But getting back, let's use your hand moving through the water causes waves to form. Now, I've already mentioned that causal statements are not logical statements. We have to translate them into logical statements, and to do that, we have to use if statements. So if A, then B. If my hand moves through the water, then a wave will form. So that's fair enough. And for many physical things, that works okay. But we have to consider cases like, let's say my hand moves through the water and it just so happens that there is a wave coming at my hand that exactly balances it out, and the destructive interference means that there's no wave. Pretty unusual situation, but it can happen. And the fact that it can happen means that statement, if my hand moves through the water, a wave will form, is false. Because there are times when my hand will move through the water and no wave will form. Might be unusual, might be weird. And so the point is that in logic we can't have that sort of thing where at one point in time something is true and at another point in time something isn't true. For the statement if A then B to be true, B always has to happen when A happens. You only need one observation of B not happening when A happens for the statement to be false. And this is partly to do with the truth table construction of how logical statements work. But for now, I don't really want to delve into that specifically. What I do want to delve into is just the whole reason why we can't have contradictory statements like that in logic. And really what it comes down to is the principle, one can call it the absurdum quodlibet. So it's a form of argument that starts from an absurdity. So if one thinks about it formally, how this works is that you have a statement that goes A and not A. So you accept both some proposition and its contradiction. And now using some of the laws of logic, what you can do is you can add different things to different things. So for example, if you have the statement A, which let's say I move my hand through the water. Now, if the statement A is true, then we can take any other statement, which we also know is true. So let's say I move my hand through the water and it's raining outside. And we can conjoin those and form a conjunction statement, A and B. So that's just what a conjunction statement is. It is true that I'm moving my hand through the water, and it is true that it's raining outside. So that forms a simple conjunction. So not too difficult to understand. So that's fine. But what we can also do is we can take a false statement, and we can say, okay, I'm moving my hand through the water, and 1 plus 1 equals 3. Now what we can say is we can say, well, since we know that it is the case that I'm moving my hand through the water, then it's also the case that either I'm moving my hand through the water or 1 plus 1 equals 3. So we know that 1 plus 1 equals 3 is false. We know that that's false. But because I'm moving my hand through the water is true, that whole statement, which only requires one of those two components to be true, either one, doesn't matter which one, the whole statement takes on a truth value, the value of true. So now the problem comes in when one uses that conditional statement together, or the conjunction together with the disjunction. So the disjunction is the or statement. So what we can do is we can use the disjunction to eliminate certain things. So let's take an example. We can say either 1 plus 1 equals 3 is true, or I'm moving my hand through the water. And then we can also say that, look, it's not true that 1 plus 1 equals 3. Therefore, it must be true that I'm moving my hand through the water. Because if we know that disjunction statement, which is 1 plus 1 equals 3, or I'm moving my hand through the water, and we know that statement is true, but we also know that 1 plus 1 equals 3 is false. So in order for those two conditions to be met, what remains is that I'm moving my hand through the water must be true. So that's pretty neat. We can use things which we know to be either true or false, together with knowing a disjunction statement, even though if the disjunction statement doesn't tell us which one of those two terms are false. When we know the value of one of them, we can, in those cases, we can tell what the other value is. So that's pretty neat. But now, if we have this contradiction that we're starting with, so we start with the contradiction that, well, let's just use A and B because it's simpler. Let's start with the contradiction A and not A. So now what we can say is we can say let's use that example again. We can say 1 plus 1 equals 3, or I'm moving my hand through the water. And we can say, okay, 1 plus 1 equals 3 is the statement A, and I'm moving my hand through the water is the statement B. So now the problem is that we know that the statement the statement. Well, we've accepted that the statement A is both false and true now. So now what we can say, well, there's several ways that we can construct this, but essentially we can use the fact that the disjunction of 1 plus 1 equals 3, or I'm moving my hand through the water, is false, together now with the fact that we know that 1 plus 1 equals 3 is true, because remember we've accepted the contradiction here, to end up with the conclusion that I'm moving my hand through the water must be false. So now we've kind of inverted the thing, because we know that those two things are are not compatible. We've said at the beginning of our discussion, we've said that I'm moving my hand through the water is true. So what's going on here? So it's a bit simpler to understand if we build it from the other direction. So and this is disjunction introduction. What we're doing now is we're introducing a term, because what we know is that whenever you have a true term, you can add anything else, whether it's true or false, to that with a disjunction, and the disjunction will still be true, because you only need one to be true. If the one you start with is true, then the adding a false term afterwards doesn't change that status. So let's go back to the beginning again. Let's say, okay, we know that I'm moving my hand through the water is true, right? And we now use disjunction introduction to add in that false term, 1 + 1 = 3. So let's turn it around as well, and let's say this time that we accept the contradiction that I'm moving my hand through the water and I'm not moving my hand through the water. So and we can imagine that this happens when we're not sure of whether that is true. So we usually how this happens, it's kind of seems like silly. How would that ever happen? But usually how it happens is in the long chain, in a long chain of argument, there'll be hidden clauses. So they won't be directly next to each other like that. And usually there might be either some equivocation. So where one word is used in two different contexts, or two different words are used to refer to the same thing, and that kind of hides it hides the contradiction. So there's all kinds of little tricks of hiding the contradiction. But essentially, once you've hidden that contradiction, you can construct that disjunction statement. And now what you can do is you can eliminate the sensible part of that contradiction, because you can now say, well, okay, we've now come to accept that either my hand is moving through the water or 1 + 1 = 3 is true. And then in another part of the argument, we've now led ourselves to believe that I'm moving my hand through the water is not true. Well, now our disjunction elimination process means that we're left with just that, what we would otherwise say, absurd conclusion that 1 + 1 = 3, which doesn't make any sense. But because we've been led there through this form of argument, it very often becomes easy to accept it. So that's a way that absurdities are used to introduce really further absurdities into an argument, and really because of this logical, I won't call it a trick, but this logical thing. It means that whenever there's a contradiction in any logical argument, anything follows. So once you accept that contradiction into the logic of your argument, you can introduce anything you like. It doesn't have to be 1 + 1 = 3. It can be Martians ate my ice cream, or whatever. Anything you like can be introduced that way, and logically, it will follow. So from a contradiction, anything follows, and this is really something to bear in mind, because what it essentially means, and the sort of the main thrust of this video is that there's no coming back from introducing a contradiction into an argument. There's no logical way back, and that will become important because as I was saying. What I was really building up to in this video, which maybe I'll leave for the next video, is the whole problem with conditionals through time, and how that affects causal statements. So, but it's really important to just get a sort of a grasp. It's difficult when I'm sort of doing it informally, like through speech, like this. But if one writes it down, it's a bit easier. This isn't really meant as an introduction to logic course, but it is important to understand the basic principle that once you introduce a contradiction into an argument, logic fails. So whatever you can have perfect logic at every step of the way after that in the argument, but logic will break down. Unless you very, very carefully sequester things. And that's where I keep coming back to the theme of needing to use caution with things like that. So you can still use logic, and this is why we can think of a lot of things being logical, even though there are subtle contradictions built into it. But that principle is very important. It's also why language in general is highly problematic when it comes to logic. And you can't really think of language as being logical in that sort of way, because it allows equivocation for terms to mean different things at different times. Because of that, it's not guaranteed that logic will break down because of that, but you can't use the fact that something looks logical in informal linguistic terms to conclude that it is logical. And in fact, the general safe assumption, and I'll probably extend this later on in the series, but the safe assumption is that if it's stated in mathematical terms or it's stated in linguistic terms or anything that isn't strict logic, that the argument is going to be illogical, is going to be logically invalid. And your job is just to figure out exactly where that invalidity lies. So it becomes a structural question rather than a question of logic at that point. So I think I'll leave it there. I think that's probably long enough for a video of this sort. So have a good one.